Okay, so good day everyone. So welcome to our second week of classes, or welcome to our second meeting for this quarter. Okay, so uh, this week we are going to study about some additional problems on arithmetic sequences, and of course we shall also be looking into arithmetic series for this week. So let's start with the first additional problem. What is the arithmetic mean between 85 and 95? Now notice that this problem is looking into inserting one arithmetic mean between 85 and 95. We know very well that the term in between two extreme terms of an arithmetic sequence is an arithmetic mean. Now, if you are going to insert just one arithmetic mean between two given terms of an arithmetic sequence, the shortcut is we just have to add the two numbers. So we have 85 plus 95. That will just give me 180. And then we divide that by 2. And that gives me 90. So therefore, the arithmetic mean between 85 and 95 must be the number 90. Let's try to look at the second problem. Insert 5 arithmetic means between negative 15 and 3. So if we are going to insert 5 arithmetic means between negative 15 and 3, then that means to say that my first term is negative 15 and that my seventh term must be equal to 3. So, from the given, a sub 1 must be equal to negative 15 and a sub 7 must be equal to 3. So, solving for the common difference now, that gives me 7 minus 1 is 6. Then append letter D. That's equal to 3 minus negative 15 is 18. So, D now must be equal to 3. So, since I now know the common difference, then I could get the second term. So, negative 15 plus 3, that gives me negative 12. Negative 12 plus 3, that gives me negative 9. Negative 9 plus 3 will give me negative 6. Negative 6 plus 3 will give me negative 3. Negative 3 plus 3 will give me 0. And 0 plus 3 will give me the last term, 3. So therefore, the 5 arithmetic means between negative 15 and 3 are negative 12, negative 9, negative 6, negative 3, and 0. Let's move to the next problem. Which term of the sequence 13, 6, negative 1, and so forth is negative 85? So from the given problem, I know that my first term is actually equal to 13 and that my common difference is equal to negative 7 and that my last term must be equal to negative 85. So we are looking for n. Okay? So that's the one we're looking for in the problem. So we have, using the formula for arithmetic, for the nth term of an arithmetic sequence, we have a sub n equals a sub 1 plus n minus 1 times d. That therefore gives me negative 85 is equal to 13 plus, I do not know n, that's what I'm looking for, times negative 7. Or that gives me negative 85 equals 13 plus or minus 7n if you distribute negative 7 plus 7. 13 plus 7 on the right side will give me 20. let's transfer 20 on the other side, or let's transfer negative 7 on the other side and 85 on the other side. So that gives us 7n is equal to 20 plus 85. So 7n now is equal to 105. Hence n is equal to 15. So therefore, negative 85 is the 15th term of the sequence 13, 6, negative 1, and so on. Let's try to look at problem number 4. The last term of an arithmetic sequence is negative 104. The common difference is negative 13. And the number of terms is 13. What is the first term? So, of course, this is an arithmetic sequence, so we have to make use of the nth term of an arithmetic sequence. That's a sub n is equal to a sub 1 plus n minus 1 times d. So, the last term, it says in the problem, is negative 104. That's equal to, the first term is unknown, so that's what we're looking for, plus the number of terms is 13 minus 1 times the common difference is negative 13. Or that gives me now negative 104 is equal to the first term plus, that's 12 times negative 13. And we know very well that 12 times negative 13 is negative 156. Okay? So, we transfer negative 156 on the other side. That gives us negative 104 plus 156 is equal to a sub 1. So therefore now, my first term a sub 1 must be equal to 52. So the correct answer now is, the first term, therefore, I should say, of the arithmetic sequence is positive 52. So let's try problem number 5. How many odd numbers are there between 5 and 112? So we are going to count the odd numbers between 4 and 112. So the first odd number is 5 that we're looking for is 5, followed by 7, followed by 9, etc. until 111. So from here, I know therefore that the last term is 111, the first term is 7, and the common difference is 2. So using the formula for an arithmetic sequence, we have a sub n is equal to a sub 1 plus n minus 1 times d. I'm looking for n. Okay, so I'm looking for n. So my last term is 111. That's equal to 5 plus, sorry, I'll just write properly my number 5. 5 plus n minus 1 times the common difference of 2. Okay, so this becomes 111 is equal to 5 plus 2n minus 2. And 5 minus 2 is 3. So what's left on the right side is 3 plus 2n. Or transfer 3 on the other side, that's 111 minus 3 is equal to 2n. Or that gives us 108 is equal to 2n. Hence, we now have a value of n which is equal to 108 over 2, that's equal to 54. Therefore, if we are going to answer the question, how many odd numbers are there between 4 and 112? There are actually 54 odd numbers between 4 and 112. Let's look at problem number 6. How many multiples of 4 are there between 8 and 125? So we are looking at the number of multiples of 4 between 5 and 125. So what's the first multiple of 4 that's found between 5 and 125? That is 8, followed by 12, 16, and so forth until 124. 124 is a multiple of 4 that is close to 125. So, again, I know my first term is 8, my last term is 124, and my common difference is 4. So, using the formula, an equals a1 plus n minus 1 times d, I'll just have to replace everything in my formula except for n because that's what I'm looking for. So that's 124 is equal to 8 plus n minus 1 times 4. Or that gives me 124 equals 8 plus 4n minus 4. So 8 minus 4 will give me positive 4. Transfer positive 4 on the other side will give me negative 4. So that's 124 minus 4 is now equal to 4n. Or 4n must be equal to 120. And solving for n therefore is equal to 30. So therefore, there are 30 multiples of 4 that are between 5 and 125. Okay, let's have the next problem. Problem number 7. In an arithmetic sequence, the second term is 9 and the eighth term is 21. Find the first term and the common difference. So we are going to look for two parameters here. We have the first term and the common difference. So the problem says that the second term is 9, so that's a sub 2 is equal to 9. And the eighth term, a sub 8, is actually equal to 21. So how do we get the common difference? The shortcut is we just subtract the subscripts. 8 minus 2 is 6. Append D. 21 minus 9 is 12. So the common difference therefore is 2. Okay? So solving for a sub 1, we use either a sub 2 or a sub 8. But it's, I think, better to use a sub 2. A sub 2, we know, is equal to a sub 1 plus D. So a sub 2 is 9. My unknown is a sub 1. And my common difference, the one that I solved, is 2. So a sub 1 now is equal to 9 minus 2. Or a sub 1 is equal to 7. So therefore, the first term of this sequence is 7. And the common difference is 2. Okay? What about problem number 8? What is the 35th term of the sequence 9, 14, 19, 24, and so forth? Okay, so before we get the 35th term, so we are looking for the 35th term, so we're looking for a sub 35. Now, before we could get the 35th term, let's try to look first at the explicit form of this sequence. Okay, so how do we get again the explicit form of the sequence? Of course, first we write a sub n equals. And then after that, we get the common difference. So 14 minus 9 will give me 5. 19 minus 14 will give me also 5. 24 minus 19 will also give me 5. So the common difference is 5. So a sub n is equal now to 5, which is the common difference. And then multiply n. Okay? And then I'm going to subtract the first term and the common difference. So 9 minus 5 will give me positive 4. So therefore, the explicit form of this sequence is a sub n is equal to 5n plus 4. Now, since I'm looking for a sub 35, then I replace n with 35. So that's a sub 35 is equal to 5 times 35 plus 4. Okay, I know very well that 5 times 35 is equal to 175 plus 4. And so a sub 35 now is actually equal to 179. So the 35th term of the sequence 9, 14, 19, 24, and so forth is equal to 179. Let's try problem number 9. What is the 47th term of the sequence 3, 9, 15, 21, and so on? So again, we're looking for a sub 47. Okay? So before we can get the 47th term of this sequence, let's try first to look into its explicit form. So a sub n is equal to, let's get the common difference. That's 9 minus 3 is 6. 15 minus 9 is 6. 21 minus 15 is also equal to 6. So that's a sub n is equal to 6n, and then subtract the first term and the common difference. 3 minus 6 is negative 3. So now I have the explicit form of the sequence of the arithmetic sequence. So I'm now ready to look for a sub 47. So I replace n with 47. So a 47 is equal to 6 times 47 minus 3. And 6 times 47 is actually equal to 282 minus 3. So 282 minus 3 will give us an answer of 279. Therefore, the 47th term of this particular sequence is 279. Let's look at problem number 10. What is the 100th term of the sequence? Negative 2, negative 6, negative 10, negative 14, and so on. So we're looking at also for a sub 100. Okay? So again, before we can get the 100th term of the sequence, let's try first to look into the explicit form of the sequence. The first thing that we do is we get the common difference of this. So negative 6 minus negative 2 will give me negative 4. Negative 10 minus negative 6 will also give me negative 4. And negative 14 minus negative 10 is also equal to negative 4. So we write now the explicit form as negative 4 times n. And then we subtract negative 2 minus negative 4 will give me positive 2. So I'm now ready to look for the 100th term. So a sub 100, I'll replace n by 100. That gives me negative 4 times 100 plus 2. And that therefore gives me negative 400 plus 2. And negative 400 plus 2 is actually equal to negative 398. So therefore, the 100th term of this sequence is negative 398. Now let's try to look at our last problem. The fourth term of an arithmetic sequence is 27 and the ninth term is 67. What is the average of the first 5 terms of the sequence? So we're looking into the average of the first 5 terms of the sequence. So we have first term, second term, third term, fourth term, and fifth term. So we know that the fourth term is 27 and the average of the terms of an arithmetic sequence is actually the middlemost term. So if there are 5 terms and we are going to get the average, The average simply is the middlemost term. So whatever the value of the a sub 3, then that is the average. So whatever this value is, that becomes the average of the first 5 terms of the arithmetic sequence. So we have a sub 4, that's the fourth term, is actually equal to 27. And the ninth term, a sub 9, is 67. So first we get the common difference. That gives me 9 minus 4 is 5. Append D equal to 67 minus 47 is 40. So clearly, D must be equal to 8. So how do we get this term here, the third term here? The third term therefore is 27 minus 8. That gives me an answer which is equal to 19. And so therefore now, okay, therefore, the average of the first 5 terms of the arithmetic sequence is actually equal to 19.